All right, looking at 4.4 fundamental theorem of calculus. So basic concept is, again, if we're looking at a bound of y equals some function f of x between a and b, then the area, as we talked about for definite integrals, actually I don't know if we talked about this or not, but the area is from a to b of f of x. And so what we're going to take a look at now is the fact that if we take the antiderivative, all we have to do is say the antiderivative evaluated at b minus the antiderivative evaluated at a. Okay, we don't need to worry about the plus c part because the f of b would have a plus c, the f of a would have a plus c, they would both just cancel out. Okay, so let's take a quick look at doing this analytically. Now we've done this with geometry. Let's take a look at doing it analytically. So if I have 3 to 4 of x squared dx, then my antiderivative of x squared is 1/3 x cubed, and again that's bumping this by 1, n plus 1, and dividing by the same thing, 1 over n plus 1 out here. Evaluated from 4 to 3 simply means plug in 4 the first time and then subtract, plug in 3 the next time. So we're looking at 64 thirds minus 9, and that's what, 27 thirds. I'm not going to work that out. I'm not in the mood. But you get the basic concept, f of b minus f of a. A quick trig one would look like the following. If I went 0 to pi of 2 cosine x, the antiderivative of 2 cosine x is 2 sine x. I can take this constant out front of the integral if I want to. And so that's evaluated from pi to 0. So the first thing I do is put in pi, 2 sine pi minus 2 sine 0. In this particular case, sine of pi is 0, sine of 0 is 0, so I get 0 minus 0, which is 0. If we'll look at this geometrically, you can kind of see that this sine graph would come up and down between then, and so the area above and the area below the x-axis would both be the same. Therefore, in the terms of definite integrals, they're just going to cancel each other out. That's why the answer is 0. Another term called average value, and this is going to come up a number of times on the AP test, is if f of x is a continuous function, and actually it says if it's integral, but continuity implies integrable. So the average value is just the height of the rectangle that has the same area and the same base. So we know that this function here, y equals x squared, is an odd-shaped function. If I want to have the same area with the same base, I just got to take my final answer for area and just divide it by the base, so it's not that bad. So I do the antiderivative of x squared is 1/3 x cubed. I evaluate from 2 to 0, which is f of 2 minus f of 0, so that's 8 thirds minus 0 thirds. That's just 8 thirds, that's area. Since we know the base is 2, I divide 8 thirds by 2, and in this particular case, that's just multiplying by a half, so that's 8/6, which simplifies to 4 thirds. So the area here, 4 thirds, is the height of the rectangle, where this rectangle has the exact same area as the area underneath the curve. All right. Mean value theorem, which I'm not even sure we'll do any of these for homework, but I'll make sure we cover this later in a little more depth, is just asking you, so for what x value does that happen? So here, as you can tell, we've looked at this average value here, and then if we can find the x value that maps to, this value c, so somewhere on the interval from 0 to 2, there maps this x value we call c, that's such that its height is the exact same as the height of that rectangle we just talked about. So the steps would look something like this. If you said find the c value in the interval from 0 to 2 such that f of c maps to that height, the first thing we would do is we would find the area. After we find the area, we divide by the base, which is division by 2, which gives us this average value, which is 4 thirds. And then, since we have average value, we set the function f of x equal to average value, and we solve for x. So in this case, our function was x squared. We set it equal to 4 thirds. We take the square root of both sides. So basically, 2 over rad 3 is the c value. And 2 over rad 3 does lie in this interval. All right, and it's the c value guaranteed by the mean value theorem. Okay, we won't hit that much in homework, but we'll see what goes on. So I've changed the homework a little bit. You'll see it on the board tomorrow, but basically I'm only going to go 1 through 15. I'm only going to take this up to about 43, and then I'm going to do some odd problems after that. But here's some basic homework problems, and I'll kind of just scroll through these for a moment. And as usual, this homework is also in probably Chapter 4 folder, labeled 4.4 Fundamental Theorem of Calculus Homework. All right, thanks.